For this video, we're going to be talking about water quality. So when we're talking about water, water is made up, we often hear it referred to as H2O, which stands for 2 hydrogen molecules for every oxygen molecule. Salt water has this composition plus salt. And we measure the salinity of salt water, which is about how much percentage of the water is salt. So in salt water, we talk about the solute is the salt, and it's being dissolved in a certain volume of water. And it's determined by per liter of water. So for example, the Dead Sea, which is salt water, the concentration of salt in the Dead Sea is 30%. So for every 1 liter of water, there is 300 grams of salt. The oceans have about 3 to 4% salt, and the Great Lakes, which is a freshwater source, has 1% concentration of salt. Because there are issues related to access to fresh water, there is a push now for technologies around desalination of salt. So the act of actually removing the salt from salt water and transforming it back into fresh water. There's also the issue of contaminants. There are different examples of different kinds of contaminants. So first are chemical contaminants. So those are things that we put on the earth that then leaches or runs off into our water system and contaminates it. So fertilizer, pesticide, and herbicide are often used in farming and agriculture. Fertilizer is used to encourage growth, and when the fertilizer mixes with the water and dissolves, it enters into the water table. And it continues to encourage growth when it's in water. And so it starts to develop algae. So sometimes we'll see lakes and things that have a high concentration of algae. That's because they have a contamination of fertilizer. Now, when the algae dies, the process of decomposition requires oxygen. So by the algae dying in the water, it's pulling the oxygen out of the water. So we no longer have H2O, we have H, which then suffocates or doesn't allow for the other organisms that live within the water to survive. Pesticides and herbicides are put onto agriculture and farms to kill insects and to deal with disease and things like that on plants so we can grow fruits and vegetables and other basic needs. These chemicals can survive for up to 5 years in the water system, and they continue to contaminate the water and wherever that water ends up. Also salt, especially in our warm climate, our cool climate in the winter, we have a practice of putting down salt and sand in the winter to prevent slipping and ice. The salt, if we think about salt water, when the salt is put down after the winter, when the snow melts, and the water from the snow goes back into the water table, it takes with it all of that salt, which is a contaminant. Acid rain. So industries and vehicles burn fossil fuels, and those fossil fuels are released into the atmosphere. And when they're released into the atmosphere, they join that water cycle. So if you think about that evaporation, condensation process of our water cycle, during that condensation process, that burning of fossil fuels gets mixed in there. So when we have that precipitation part of the cycle, when the water is coming down, it's mixed in with other chemicals. So those other chemicals are being now brought down back onto the earth. They land on forests and grass and farms and rivers, continuing that cycle of contamination. Transportation. So the transportation of harmful chemicals sometimes goes wrong. So we could be transporting these chemicals by train, by boat, by land, and something happens and there's an accident and these things are spilled into our natural environment. They can never be completely cleaned up, and then it affects the water table in that environment. And then there are biological contaminants. So biological contaminants are things that naturally occur on the Earth's surface, and they end up getting into the water cycle, the water table. So when there is a high level of precipitation and we have runoff, those organisms and waste and things that are on top of the surface can get washed into the river system. So just think about simply a farmer's field. If there is a high level of precipitation and there's runoff on the field, there might be animal matter, animal waste that gets run off into a nearby river. And that could cause microorganisms and diseases and things to occur. This is what happened in Walkerton when there was an E. coli outbreak. It was due to the runoff of cattle waste, and 7 people died. And those parasites would not be something that we would see necessarily in the water, and so it can be very dangerous. Parasites are another organism that can be in the water, and parasites are a living organism that survive off of their host. So if there is a biological parasite that is in the water and we ingest the water, we become the host and we feed the parasite, and then we can become very ill because we have that parasite inside of us. So here are some examples of microorganisms. So Salmonella, E. coli, Giardia, and these can come from domestic sewage, like our regular everyday sewage, cattle and livestock, and other natural sources, because they naturally exist in our environment. Organic matter, such as animal waste, you can have it can come from industrial waste, it can come from farm sewage, and these would all be examples of biological contaminants that would have a terrible impact on our water and our water system.